Hello, my name is Adolfo Neto. I'm a professor at the Federal University of Technology, Paraná, here in Curitiba, Brazil. And I teach this course, Introduction to Functional Programming. And what I'm going to do today is to give a brief review of my first class. It was last week. Basic Concepts for Functional Programming. So what I presented is that you have for understanding functions, first you have to understand values. So what's a value? It can be a number or a word or a phrase. John lives in Curitiba. So these are values, examples of values. And of course, when you talk about numbers, you have integer numbers or real numbers. 93.76. And you can also have Boolean values like true and false, and many more. But the second concept that I want everyone to understand is that of a set. So you can have the empty set, which is a set with no elements. You can have a set with three numbers, or you can have a set with a number, a word, a phrase. John is going to the beach, and true. These all are sets. So an empty set has no element. This set has three elements. This one has four elements. You can also have a set like 1, 2, 3, 4, 5, 6, and so on, which is an infinite set. And this set is the set of natural numbers. It has a special name, and there are some other sets in mathematics that have special names. The real numbers, which contain 0, -1, 0.05, and so on. The sets we are interested in are, I believe this in, not on, have one or more elements. Infinite sets are okay, but for the examples here, I'm going to use mostly sets with finite sets. Some basic properties of sets are there. The order is not important. What does this mean? It means that the set 2, 3, 4 is the same set as 3, 4, 2, which is the same set as 3, 2. And the other point is that there is no repetition. So this is not, this and this are the same set. There is no set with two occurrences of 2. It's the same set. Famous sets, natural numbers, integers, reals. And what's a relation? Well, to understand what's a relation is also a set, but let me first show you an example. Suppose you have a set A containing 1, 2, 6, and a set B containing A, B, A and B, it's okay. And I can have a relation R where, for instance, I can get 1A, 2B, 2, no, sorry, 6A, 6B. My 6 is ugly. But what's my point here? Let me use the color. So 1, 2, 6 come from A. A, B come from B. So this relation R is a subset of the Cartesian product of A and B. It's a set of tuples. So I showed you and I didn't explain, but this is a tuple. In this case, the tuple contains two elements, and for tuples, the order is important. So 1A is different from A1. The order is important. And you can have repetitions. For instance, you can have a tuple such as AA or 1, 1. So it's a sequence of values. In this case, this R relation here, it's a set of tuples where the first element comes from A, the second element comes from B. And why do I say it's a subset of the Cartesian product? Because suppose you have, let me copy this to the other screen. So the Cartesian product of these two sets would be this. Let me. A, it's all the tuples that can use the one element from one set, the other element from the other set, 1A, 1B, then 2A, then 2B, then 6A, and finally 6B. So this is the Cartesian product of A and B, and it's also a set. So the definition, a relation is also a set. I'm using the word tuple, but you can have, this is a tuple, 2, and this is also a tuple. So it's maybe I could call this a triple and a quadruple. And this is not important. For tuple is the generic name. I presented the students several ways to see a function, as shown by Carniel Epstein in this book. These are only a few pages from this book, Computability, Computable Functions, Logic, and the Foundations of Mathematics. I believe you can find this book on Amazon and other online bookstores. Carnielli, Computability, yes. See, hardcover. I believe there is no Kindle version. Maybe there is, but as I am in Brazil, I'm not going to discuss this here because I want to end by saying that how I see a function it's a function is also a relation. But let's get another set. Let me go back to that set. It's again, let me copy this and paste it here just that now I'm going to show this set in a different way. So it's 1, 2, 6, and here is A and B. So a function, suppose I have a function f. It has to associate to each element of A an element of B. So right now this is not a function. Why? Because 1 is associated to A, but 2 is associated to nothing. So right now this is not yet a function, because 1 is associated to B, to A, 2 associated to B, but 6 is associated to nothing. Now we have a function. This function could be described as f from A to B, f of 1 equals to A, f of 2 equals to B, f of 6 equals to B. And you could also see this function as a relation 1A, 2B, 6B. You see, it's a different way to see the same, but it's better to represent it this way. And what's not a function? I already told you that if you don't associate one element here to the other, to an element of B, it's not a function. And this would also not be a function. If I associate 1 to 2 values, it's not a function. So let me undo it, and this line is going to disappear. Okay, now it's a function. But let's take a look at this relation here. Let me try to draw here. So it's 1, 2, 6, A, B. Here you have 1A, 2B, 6A, and 6B. That's not a function. That's only a relation. This relation is not a function, so all relations are functions, but many functions are not relations. And I'm not going to discuss the identity, increment, decrement functions here, but yes, not arity. But what I want to end this discussion here is that I presented here the idea of a function, a mathematical function, and in functional programming we usually use the term pure function to represent a mathematical function, and impure function to represent a relation that is something that is not a function. I'm simplifying it here because, of course, impure function also deal with states, which is another discussion that I'm going to have with my students tomorrow. But I believe that's enough for now. Sometimes I see, people use the term impure function when they could have the impure function when they could use relation to say, this is not a function. But okay, it's traditional in computing, in programming. When I studied Pascal several years ago, we used the term, the keyword function to represent something which was not necessarily a mathematical function. That's why when people created functional programming language, they used this term mathematical or pure function to describe mathematical functions. And that's it. If you want to join us, I'm recording this on September 27th, 2022. If you want to join us, you still can, but that's go to my Twitter account at Adolfo20 and you get more information about that. See you next video. Bye bye.